Alright, let's talk about clearing fractions, everybody's favorite thing to do. But I'm going to make your life a little bit easier with these fractions, and you're going to appreciate it when I am finished. When we are talking about working linear equations that contain fractions, we're going to clear our fractions and make our lives a little bit easier. So clear fractions, and the way we're going to do that, we are going to find the LCD of all the fractions. So you're still going to have to find an LCD, okay? But we're not going to have to do the making the equivalent fraction part. The second thing you're going to do is multiply all terms by the LCD. And then you will solve your equation. Now, once you multiply all your terms by the LCD, this should clear out your fractions and you won't have any other fractions to have to deal with. Now, you may still get an answer that's a fraction, but it's going to make the work in between a little bit easier. So let me show you what I'm talking about. I've got 2/5 x minus 3/10 equals 1/2. The first thing I need to do is decide what my LCD is for 5, 10, and 2. Well, that's going to be 10 because all three of those numbers go into 10. I'm going to rewrite my problem down here so I can write a little bit larger. Alright, so what I'm going to do is I'm going to multiply each term times 10. Now, the book is going to show just the 10 written one time in one big parentheses next to each one, and then you distributive property that 10 through there. I like to write my 10 next to every term so then I can do the canceling one at a time and I don't lose anything that way. So 5 goes into 10 2 times. 2 times 2x is going to give me 4x. On this one, the 10's cancel, so I have a minus 3 equals 2 goes into 10 5 times. 5 times the 1 is 5. Now see, now I have an equation that does not have fractions in it. I can go back to my my rules for solving equations. So the first thing we need to do is add or subtract to both sides to get that variable by itself. So I'm going to add 3 to both sides. So 4x equals 8. And then to get x by itself, I need to divide both sides by 4. So then x equals 2. That's my final answer. If I want to check this, you could go back in and put the x in for your 2 and check it and make sure it's correct. I'm not going to go through the checking part because I want to get to some of these that are a little bit longer to be able to solve. So you can see the next one. I've got a 1/3 x minus 5/6 equals 3/4 x plus 2. So I'm going to find an LCD for all of the fractions 3, 6, and 4. A number that 3, 6, and 4 will all go into would be 12. So I'm going to rewrite the problem again down here so that I can write it a little bit bigger so you can see how I do all of the canceling. Now, I've got 3/4 x plus a 2. Now remember, my rule says that I'm going to take my LCD times every term. So do you think I'm going to take that LCD times the 2 here on the end? The 2 doesn't have a fraction, but my rule says to multiply it times every term. So remember, equations are all about keeping things balanced. One side to the other side. Whatever you do to one side, you have to do to the other. So if I'm going to multiply by 12 on some of the terms, I have to multiply by 12 on all of the terms. So 3 goes into 12 4 times. 4 times 1x is 4x minus 6 goes into 12 2 times. The negative 5 times 2 would be negative 10 equals 4 goes into 12 3 times. 3 times 3x would be 9x plus, now this time I don't cross cancel because it's 2 times 12, which is 24. So now I have an equation that doesn't have fractions in it, but I have variables on each side, and we've talked about those, so I need to move my variables to one side, so I'm going to subtract 9x from both sides. So 4x minus 9x is negative 5x minus 10 equals 24. Now I need to move the 10, so I'm going to add 10 to both sides. So negative 5x equals 24 plus 10 would be 34. I'll come over here and finish it. Negative 5x equals 34. So I'm going to divide both sides by the negative 5. So, you know, I told you that you may end up with a fraction for an answer, but that's okay. We didn't have to deal with fractions and changing to equivalent fractions in the middle. My problem is a lot easier when I cancel my fractions. Okay, let's work some more. I've got negative 1/9 p minus 5 over 18 excuse me, equals negative 1/6 p plus 1/3. 9, 18, 6 and 3, LCD would be 18. All four of those numbers go into 18. So I'm going to try and do the 18 next to here and see. It's going to get a little bunchy. I may have needed to have rewritten it. I hope I don't forget that negative in front of that 6p. Okay, so 9 goes into 18 2 times. 2 times a negative 1p would be negative 2p. 18s would cancel in this one, so I just have the minus 5 equals 6 goes into 18 3 times. Negative 1 times 3 is negative 3, and there's a p there with that one. 3 goes into 18 6 times. 6 times 1 is 6. Again, I've got variables on both sides, so I need to bring my variables together. So I'm going to add 3p to both sides. P and b. Negative 2 plus 3 gives me a 1p. Minus 5 equals 6. And then I need to move the 5, the negative 5. So I'm going to add 5 to both sides. So p equals 6 plus 5 is 11. Now you can see over here on the left side of the page how I told you that the book will a lot of times just write the LCD one time and then have you do your distributive property. I don't even go through that step. I go straight to this step and write it next to each term, just so I can see the cross canceling. It just helps me. Now this one's a little bit different because this time we have some parentheses going on with our fractions. So if you have parentheses, with our fractions, still find the LCD. And we're just going to multiply the outside fractions by LCD. I'm going to say outside fractions or numbers. It could be whole numbers. So in this case, I've got a 1/2 and a 1/7. So my LCD would be 14. Now, I'm not going to multiply the inside of these parentheses by 14. They're protected by those parentheses. So I'm going to multiply the 14 times the 1/2. Let me take out that parentheses. Let's do this. We're going to put 14 times my 1/2, and then I have x minus 3 plus, I'm going to have 14 times the 1/7 times x plus 1. Now I still need to take the 1 times 14 because that doesn't change. I still am working with both sides, but it's just that the inside of these parentheses are protected. So 2 goes into 14 7 times. So I have 7 times x minus 3 plus 7 goes into 14 twice. 2 times x plus 1 equals 1 times 14 is 14. And now we're going to solve this one. We first have to clear our parentheses. So 7 times x is 7x. 7 times a minus 3 is a minus 21. 2 times x is 2x. 2 times 1 is 2 equals 14. Now the most commonly skipped step is are collecting the like terms in this step. So don't forget, collect your like terms. Make your problem smaller. 7x plus 2x is 9x. Minus 21 plus 2 would be minus 19 equals 14. Add our 19 to both sides. So 9x equals equals 33. Continue it over here because I ran out of room. Divide both sides by 9. So x equals 33 over 9. Again, we ended up with a fraction, but in the middle part, much easier to work without having those fractions in that have to add and subtract. Alright, so that one, I believe, is the same problem. So we're going to go, they just gave me extra room and I already used it up. Let's do this one in the middle. I've got a 1/3 and a 1/2. So the LCD would be 6. That's what they both go into. So I'm going to take a 6 times this one, 6 times here, and then the 4 times 6. So 3 goes into 6 2 times. So I'm going to have a 2 times x plus 3 plus 2 goes into 6 3 times. 3 times x minus 4 equals 4 times 6 is 24. So now let's distribute 2x plus 6. Distribute my 3 and have 3x minus 12 equals 24. So now collect like terms. 2x plus 3x is 5x. 6 minus 12 gives me negative 6 equals 24. And now we're back to solving. So we're going to add 6 to both sides. So 5x equals 24 plus 6 is 30. Divide by 5. So final answer, x equals 6. Much easier when we clear these fractions. Now sometimes your fractions may look like this. So I'm trying to show you all the different ways you could see fractions. These are fractions, these are equations with fractions in them. They just chose to put the denominator in underneath that expression x plus 3 and 3x minus 1. But it's still, they're still fractions. So on this one, for 3 and 2, my LCD would be a 6. We had a 6 while ago, so I'm going to take a 6 times this fraction, a 6 times this fraction, and then the 1 is going to get multiplied by 6 as well. So 3 goes into 6 2 times. So now I'm going to add some parentheses. 2 times x plus 3 minus 2 goes into 6 3 times. 3 times 3x minus 1 equals 1 times 6 is 6. So you see different looks for fractions. We can write fractions a little bit different each time. 2 times x is 2x. 2 times 3 is 6. Minus 3 times 3x is minus 9x. Minus 3 times a minus 1 is a plus 3 equals 6. And now let's keep going with our rules. 2, let's collect like terms. That'll be negative 7x plus 9 equals our 6. Let's subtract 9 from both sides. So negative 7x equals negative 3. Divide both sides by negative 7. On this one, the fraction doesn't really reduce, but the two negatives would cancel each other out, giving me positive 3/7. Alright, here is one as well. This is just like the one that I just worked. Again, we're finding an LCD, so the LCD for 4 and 3 would be 12. So both 4 and 3 go into 12. So I'm going to multiply everything times 12. Even the 2. So 4 goes into 12 3 times, so I'm going to have 3 times x plus 2 minus 3 goes into 12 4 times, so 4 times x minus 1 equals 2 times 12 is 24. Clear your parentheses. 3x plus 6. Watch your signs on this next one. Negative 4x plus 4 equals 24. Collect like terms. 6 plus 4 is going to give me 10 equals 24. Subtract 10 from both sides. We careful with your signs. Negative 1x equals 24 minus 10 would give me 14. I need a positive x though, so divide both sides by negative 1. So x equals negative 14. So the problems are much easier when you go through and you clear these parentheses. It just makes it a ton easier. Alright, if you have any questions, be sure and get with your instructor. That's how you clear fractions.